Hello everyone. Today I will be presenting on topic heart failure prediction. The goal of my project is to create a model that can reliably predict heart failure in patients using various ML techniques. Introduction. Heart failure is the critical condition affecting millions of people worldwide, characterized by heart's inability to pump blood effectively. Early intervention is essential for improving patients' outcome and reducing death rate. Traditional methods often rely on clinical judgment and basic statistical model, which may not capture patterns in data that indicate risk of heart failure. Problem statement. The goal of this project is to develop a predictive model using patient clinical data to classify individuals into high risk or low risk of heart failure by analyzing key medical features such as age, ejection fraction, serum creatinine levels, and follow-up time. We aim to assist healthcare professionals in identifying patients at risk of heart failure. Objective. The primary objective of this project is to develop a robust machine learning model that can accurately predict heart failure risk in patients. The model aims to analyze patient data to identify patterns indicative of heart failure, provide healthcare professionals with a reliable tool for early diagnosis and intervention, improve patient outcomes through timely and personalized treatment plans, enhance the overall efficiency of heart failure management in clinical settings, and provide insights into most significant risk factors which is contributing to heart failure. Dataset overview. The dataset contains clinical records of heart failure patients. The total number of records is 299 and total features is 13, and it contains no missing values, and all the values are in numericals, and which is in floating and integer type, and our target variable is death event, in which 0 indicate survived patients and 1 indicate died patients. Model selection. These are the models that we included in our project. The model used are logistic regression, support vector machine, k nearest neighbor, decision tree classifier, Gaussian naive Bayes classifier, random forest classifier, and XGBoost classifier. Model description. Logistic regression. Logistic regression is a fundamental statistical and machine learning model used for binary classification problems, and it is best for understanding linear relationship between features and heart failure risk. Support vector machine. SVM is a supervised ML algorithm which is effective in handling high dimensional spaces and small datasets. Random forest classifier, an assemblance model that improves accuracy by combining multiple decision trees. XGBoost classifier. It is a gradient boosting model that optimizes both speed and accuracy. Classifier. It is easy to interpret and capture nonlinear relationships in the dataset. KNN. It works comparing patient data to similar cases in the dataset. Heart Failure Prediction Web App. This is a heart failure prediction app built using Streamlit, a Python framework for creating interactive web applications. This app allows users to input key clinical parameters to predict whether a patient is at risk of heart failure. Users can adjust values for different clinical features using sliders, making it user-friendly. Once values are set, user can click Predict to get the model's prediction. It will predict whether the patient is at high risk or low risk of heart failure. It displays easy to understand result to assist healthcare professionals for predicting heart failure in patients. Visualization. These are the donut charts showing survival status on various features. Survival status on smoking. From this donut chart, we can see that 45.82 smokers did not survive. Survival status on sex. From this chart, we can see that the majority is the survived male, which is 41.1 percentage. Survival status on diabetes. From this chart, we can see that 39.5 percentage survived without diabetes. Survival status on anemia. From this chart, we can see that 40.1% survived without anemia. Survival status on high blood pressure. From this chart, we can understand that 45.8% survived without high blood pressure. Dashboard. This is the dashboard created using Tableau using different charts. The first chart shows the distribution analysis of death event, which shows majority of the data in the data sets shows death rate is more than those who surveyed. And the second chart shows the well-axis chart for time versus ejection fraction and serum sodium, in which serum sodium is indicated in yellow dots. Lower ejection fraction and lower sodium levels might be linked to an increased risk of death. And third shows anemia, diabetes, and smoking versus death event, which shows anemia and diabetes significantly correlates with death failure risk. Smoking has an effect, but it may be less dominant compared to other clinical factors. Age versus ejection fraction. This scatter plot shows ejection fraction across different ages. A low ejection fraction is common across different age groups. Patients with higher ejection fractions tend to be younger, suggesting age-related heart function decline. And fifth chart shows age distribution of patients. In this histogram showing age distribution of patients in the dataset, which indicate middle-aged and older individuals are more likely to experience heart failure. Result: Decision tree achieved the highest accuracy, making it the top performance model, and the accuracy is 88.89%. Logistic regression and XGBoost also showed strong predictive performance. Logistic regression shows 87.78% accuracy and XGBoost shows 86.67% accuracy. This is the bar chart showing accuracies of different models that we have used in this project. Conclusion: the project successfully developed a heart failure risk prediction model using machine learning. Among the model tested, decision tree shows higher accuracy of 88.89%. Key medical features like ejection fraction, serum creatinine, time, and age played a crucial role in risk prediction. The model can assist healthcare professionals in early diagnosis and patient risk assessment. This project not only aims to improve operational efficiency but also seeks to support public health and resilience by providing reliable, real-time insights into a heart failure risk. Thank you.